of linear equations in two variables. Akila went to a fair in her village. She wanted to enjoy rides on the giant wheel and play hoopla. The number of times she played hoopla is half the number of rides she had on the giant wheel. If each ride costs rupees 3 and a game of hoopla costs rupees 4, how would we find out the number of rides she had and how many times she played hoopla, provided she spent rupees 20? We can find the answer by solving linear equations in two variables. Denote the number of rides that Akila had by X and the number of times she played hoopla by Y. Now the situation can be represented by the two equations. Y is equal to half X, this is equation 1, and 3X plus 4Y is equal to 20, equation 2. Pair of linear equations in two variables. The following are examples of linear equations in two variables. 2x plus 3y is equal to 5, x minus 2y minus 3 is equal to 0, and x minus 0y is equal to 2, that is x is equal to 2. We also know that an equation which can be put in the form of ax plus by plus c is equal to 0, where a, b and c are real numbers and a and b are not both 0, is called a linear equation in two variables x and y. We often denote the condition a and b are not both 0 by a square plus b square not equal to 0. The general form for a pair of linear equations in two variables x and y is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, where a1, b1, c1, a2, b2, c2 are all real numbers and a1 square plus b1 square is not equal to 0, a2 square plus b2 square is not equal to 0. For example, Romila went to a stationery shop and purchased 2 pencils and 3 erasers for rupees 9. Her friend Sonali saw the new variety of pencils and erasers with Romila and she also bought 4 pencils and 6 erasers of the same kind for rupees 18. Represent the situation algebraically and graphically. Solution. Let us denote the cost of 1 pencil by rupees x and 1 eraser by rupees y. Then the algebraic representation is given by the following equations. 2x plus 3y is equal to 9. Equation 1 and 4x plus 6y is equal to 18. Equation 2. To obtain the equivalent geometric representation, we find 2 points on the line representing each equation. That is, we find 2 solutions of each equation. These solutions are given below in table. In first equation, when x is equal to 0, y is equal to 3, and when x is equal to 4.5, y is equal to 0. Similarly, for second equation, when x is equal to 0, y is equal to 3, and when x is equal to 3, y is equal to 1. We plot these points on a graph paper and draw the lines. We find that both the lines coincide. This is so because both the equations are equivalent, that is, one can be derived from the other. Graphical method of solution of a pair of linear equations. Lines representing a pair of linear equations in two variables and the existence of solutions as follows. If lines are intersecting, then a1 upon a2 is not equal to b1 upon b2. If lines are coincident, then a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. If lines are parallel, then a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Algebraic methods of solving a pair of linear equations. In the previous section, we discussed how to solve a pair of linear equations graphically. The graphical method is not convenient in cases when the point representing the solution of the linear equations has non-integral coordinates like root 3 and root 2, 7, minus 1.75 and 3.3, 4 by 13 and 1 by 19, etc. There is every possibility of making mistakes while reading such coordinates. So we will now learn several other alternative methods of finding the solution. Substitution method. We will understand this method of substitution by taking an example. Solve the following pair of equations by substitution method. 7x minus 15y is equal to 2, equation 1. X plus 2y is equal to 3, equation 2. Solution. We pick either of the equations and write one variable in terms of the other. Let us consider equation 2, x plus 2y is equal to 3, and write it as x is equal to 3 minus 2y. This is equation 3. Substituting the value of x in equation 1, we get 7 into 3 minus 2y minus 15y is equal to 2. That is 21 minus 14y minus 15y is equal to 2. We get minus 29y is equal to minus 19. Therefore, y is equal to 19 upon 29. Substituting this value of y in equation 3, we get x is equal to 3 minus 2 into 19 upon 29. That is equal to 49 upon 29. Therefore, the solution is x is equal to 49 upon 29 and y is equal to 19 upon 29. Elimination method. Now let us consider another method of eliminating, that is, removing one variable. This is sometimes more convenient than the substitution method. Let us see how this method works. The ratio of incomes of two persons is 9:7 and the ratio of their expenditures is 4:3. If each of them manages to save rupees 2000 per month, find their monthly incomes. Solution. Let us denote the incomes of the two persons by rupees 9x and rupees 7x and their expenditures by rupees 4y and rupees 3y respectively. Then the equations formed in the situation is given by 9x minus 4y is equal to 2000, equation 1, and 7x minus 3y is equal to 2000, equation 2. Multiplying equation 1 by 3 and equation 2 by 4 to make the coefficients of y equal, we get 27x minus 12y is equal to 6000, equation 3, 28x minus 12y is equal to 8000, equation 4. Subtracting equation 3 from equation 4 to eliminate y because the coefficients of y are the same. So we get 28x minus 27x minus 12y minus 12y is equal to 8000 minus 6000. That is, x is equal to 2000. Substituting this value of x in 1, we get 9 into 2000 minus 4y is equal to 2000. That is, y is equal to 4000. So the solution of the equations is x is equal to 2000, y is equal to 4000. Therefore, the monthly incomes of two persons is rupees 18,000 and rupees 14,000 respectively. Use elimination method to find all possible solutions of the following pair of linear equations. 2x plus 3y is equal to 8. This is equation 1. 4x plus 6y is equal to 7. This is equation 2. Solution. Multiply equation 1 by 2 and equation 2 by 1 to make the coefficients of x equal. Therefore, 4x plus 6y is equal to 16, equation 3. 4x plus 6y is equal to 7, equation 4. Subtracting equation 4 from equation 3, 4x minus 4x plus 6y minus 6y is equal to 16 minus 7. That is, 0 is equal to 9, which is a false statement. Therefore, the pair of equations has no solution. Cross multiplication method. So far, we have learned how to solve a pair of linear equations in two variables by graphical, substitution and elimination methods. Now we will introduce one more algebraic method to solve a pair of linear equations, which for many reasons is a very useful method of solving these equations. Let us now understand this method for any pair of linear equations in two variables of the form a1x plus b1y plus c1 is equal to 0. Equation 1 and a2x plus b2y plus c2 is equal to 0. Equation 2. 1. When a1 upon a2 is equal to b1 upon b2, we get a unique solution. 2. When a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, there are infinitely many solutions. 3. When a1 upon a2 is not equal to b1 upon b2 is not equal to c1 upon c2, there is no solution. The solution of the equation can be written in the form x upon b1 c2 minus b2 c1 is equal to y upon c1 a2 minus c2 a1 is equal to 1 upon a1 b2 minus a2 b1. Above rule can be remembered easily with the help of this diagram. For example, from a bus stand in Bangalore, if we buy 2 tickets to Malleshwaram and 3 tickets to Yeshwanthpur, the total cost is rupees 46. But if we buy 3 tickets to Malleshwaram and 5 tickets to Yeshwanthpur, the total cost is rupees 74. Find the fares from the bus stand in Bangalore to Malleshwaram and to Yeshwanthpur. Solution. Let rupees x be the fare from the bus stand in Bangalore to Malleshwaram and rupees y to Yeshwanthpur. From the given information we have 2x plus 3y is equal to 46. That is 2x plus 3y minus 46 is equal to 0. Equation 1. 3x plus 5y is equal to 74. That is 3x plus 5y minus 74 is equal to 0. Equation 2. To solve the equations by the cross multiplication method, we draw the diagram as given below. Then x upon 3 into minus 74 minus 5 into minus 46 is equal to y upon minus 46 into 3 minus 74 into 2 is equal to 1 upon 2 into 5 minus 3 into 3. Therefore, x upon minus 222 plus 230 is equal to y upon minus 138 plus 148 is equal to 1 upon 10 minus 9. That is, x upon 8 is equal to y upon 10 is equal to 1 upon 1. That is, x is equal to 8 and y is equal to 10. Hence, the fare from the bus stand in Bangalore to Malleshwaram is rupees 8 and the fare to Yeshwanthpur is rupees 10. Find whether the given pair of linear equations has unique solution, no solution, or infinitely many solutions. X minus 3y minus 3 is equal to 0 and 3x minus 9y minus 2 is equal to 0. Solution. Here, a1 is equal to 1, b1 is equal to minus 3, c1 is equal to minus 3, a2 is equal to 3, b2 is equal to minus 9 and c2 is equal to minus 2. Therefore, a1 upon a2 is equal to 1 upon 3, b1 upon b2 is equal to minus 3 upon minus 9, that is equal to 1 by 3, and c1 upon c2 is equal to minus 3 upon minus 2, that is 3 by 2. a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Hence, the given pair of equations have no solution. Equations reducible to a pair of linear equations in two variables. Solve the following pair of equations by reducing them to a pair of linear equations. 5 upon x minus 1 plus 1 upon y minus 2 is equal to 2. 6 upon x minus 1 minus 3 upon y minus 2 is equal to 1. Solution. Let us put 1 upon x minus 1 is equal to p and 1 upon y minus 2 is equal to q. Then the given equations, 5 into 1 upon x minus 1 plus 1 upon y minus 2 is equal to 2, and 6 into 1 upon x minus 1 minus 3 into 1 upon y minus 2 is equal to 1 can be written as 5p plus q is equal to 2, equation 1, and 6p minus q is equal to 1, equation 2. Multiply equation 1 by 3. 15p plus 3q is equal to 6, equation 3. 6p minus 3q is equal to 1, equation 4. Adding equations 3 and 4, we get 21p is equal to 7. That is, p is equal to 1 by 3. Also, q is equal to 1 by 3. Now resubstituting 1 upon x minus 1 for p, we have 1 upon x minus 1 is equal to 1 by 3. Therefore, x minus 1 is equal to 3. That is, x is equal to 4. Similarly, substituting 1 upon y minus 2 for q, we get 1 upon y minus 2 is equal to 1 by 3. That is, y is equal to 5. Hence, x is equal to 4, y is equal to 5 is the required solution of the given pair of equations.